Hey everybody, this is Mr. McKee again with Net 125. Today I'm going to be going over Packet Tracer 11.7.5, which is subnetting scenario. Alright, so our addressing table is pretty much empty. Looking at our topology, we have two routers. Each of those routers has two LANs connected to it, each with 25 hosts. Alright, so scenario, in this activity you are given a network address of 192.168.100.0 with the CIDR 24 to subnet and provide the IP addressing for the packet tracer network. Each LAN in the network requires at least 25 addresses for end devices, the switch and the router. The connection between R1 and R2 will require an IP address for each end of the link. Alright, so it's talking about that right there. Alright. So design an IP addressing scheme. Subnet the 192.168.100.0 network into the proper number of subnets. Based on the topology, how many subnets are needed? Alright, so once again, I'm going to be using my spreadsheet. I'm not going to call it a calculator, but I have IP calculator, but I want to do it all manually so I can make sure I know how to do it. Now the network we know we're going to be using is 192.168.100.0. Alright, with the /24. It didn't like me to do that. /24. Alright, so that's that. We need at least 4 subnets with 25 hosts each. So if we look through here, the number of hosts I'm looking for a number that's over 24 but not way over it. Alright, so 30 looks like a pretty good candidate, and that'll give us 8 subnets of 30 hosts, or 8 times 32 possible addresses. Alright, so right here where I have all the ends for network address. Alright, and then I'm going to say all these will be subnets. Alright. So how many bits must be borrowed to support the number of subnets in the topology table? Now to borrow 4, you could technically borrow 2 bits, just like that, because this would have a possible subnet of 0 or 1, and this could have a 0 or 1. So you could just do a /26. Alright. How many subnets does this create? That would create 4 subnets if you used a /26. How many usable hosts does this subnet create per subnet? How many hosts does this create per subnet? If you did a /26, that would give you 62 usable addresses per subnet. And see how the last packet tracer, it wasn't very specific, but that's very specific. How many usable hosts does this create per subnet? Alright. If your answer is less than 25 hosts required, then you borrowed too many bits. Alright. Calculate the binary value for the first 5 subnets. The first 2 subnets have been done for you. Alright, and then I need to do a format painter on that. Alright, And then I'm going to do like this. If you're in my class, you'll have to fill this out, but not a big deal. Okay. And notice how let me look back at this. How many bits must be borrowed to support the number of subnets in the topology table? Now, just so you know, just looking at this, I can tell that they're going to borrow 3 bits. So really, they're going to have 8. You can have 8 subnets, 30 hosts per subnet. You could actually do it, if you want to just borrow 2, that would just give you larger subnets. That would give you 4 subnets of 62 hosts per subnet. But since they're doing, that's actually 5 subnets right there. Well, they're using this as a subnet also. I don't know if that's good or bad, but that's the way they're doing it. All right, so they're saying counting bits from 0, 1, 2, 3, 4, 5, 6, 7. So starting at 0, those are 8 bits on the 4th octet. They're saying 0 is just no borrowed bits. 1 is borrowed bit there. So all these will be 0 anyways. And I'm going to make these red. Alright, 0, 0, 0, 0, 0. Remember, all of these bits will be used for hosts. So that'll be 0, 1, 0. And then this will be 0, 0, 0, 0, 0, 1, 1, 0. And this will be 0, 0, 0, 0, 0. Alright. It's going to take this one, move this one there, 1. Alright, so it would be 1, 0, 0. Alright. I believe it did that right. Alright, so out of these 3 subnets, 0, 1, 2, 3, 4. Okay, just like that. It's hard for me to visualize how that works, but I mean, I understand how it works, but yeah. So calculate the binary and decimal value of the new subnet mask. Okay. So if we're borrowing, it's going to be 27. 128, 192, 224. So I'm going to format painter this. Alright, so it's going to be a 224. Whoops. Alright, so it'll be like that. Now, the actual bitwise, let me do a format painter. Alright, this. Now to make a 224, you need to do a 0, 0. Let's make sure I'm doing that right. So it would be 128, 192, 224 0 0 0 0 0. All right, so if I did my calculator, I'm sure that's right, but I just want to add it up. All right, 28 plus 64 plus 32. All right, 224. Yep. All right, fill in the subnet table listing the decimal value of all available subnets, the first and last usable host address, and the broadcast address. Repeat until all addresses are listed. And when it says subnet address, is referring to the network address of the subnet. And I'm going to format painter this. All right, so 192.168.100.0. All right, 192.168.100.1. All right, now we can do our calculations over here. It's a 224, which is a \27 to 128.192.224. Okay. All right, so our first usable host address, and I'm going to leave all those the same for now. All right. Actually, 255.255.255.28. I always like to calculate on my fingers to make sure I'm right. All right, 192.168.100.1. All right, last host address, 192.168.100, and so we're doing a 224. So if we did 256 minus 224, all right, 32 addresses per subnet, and I want to verify on here. All right, 32 addresses per subnet, so 30 usable addresses. So 30. All right, 31 would be our broadcast. All right, and from now on, I'm just going to do dots. I'm going to leave off the first 3 octets. So 30.31. All right, come back around .32. All right, first usable host address is going to be .33. All right, and if I go through here and change this network's going to be 32. First usable host address is 33. If I add, I have 30 usable addresses, so if I added 29 more to 33, 33 plus 29 more equals 62. 62, broadcast 63. I know broadcasts are odd, so that looks correct. So dot 62, 63. All right, dot 64 is the next one. network address, then .65. Okay, I said okay, 65 plus 29 more would be 94.94.95. Whoops, is broadcast. .96.97. All right, 97 plus 29 more to make 30 is .126. .127 is the broadcast. This would be .128. All right, .129. All right, 129 plus 29 more, so it would be 158.158.159. Whoops. So they have a whole list of these things. All right. Let's format painter these. All right, .160. All right, .161. All right, .161 plus 29 more. Oops. 161 plus 29 more. 190. .190.191. All right. .192. .193. All right. 193 plus 29 more is .222. .223. All right. All right. .224. .225. Hopefully you're seeing the pattern now. But 225 plus 29 more, 254. Notice .254. And finally, luckily, we ended up with .255 as the very last possible broadcast address for our fourth octet. All right, we split it up in 32 address subnets, and if you did 256 total addresses divided by 32 possible addresses per subnet, that would give you 8 subnets. So we got, did it mess up? Divided by 32, 8 subnets, 1, 2, yeah, that's right, because first subnet 0, 1, 2, 3, 4, 5, 6, 7, 8, all right? I know that's confusing when it starts out counting, because you could say 0 is the first subnet. If you wanted to give that a number of 1, that would kind of make sense if you say that's the first subnet, but it's actually subnet 0. But you wouldn't refer to it like that because that would be confusing. You just say, okay, my first subnet is this, is 192.168.0.100.0, not subnet number whatever. But if you said, how many subnets do I have? I have 8 subnets. The first one is a .0, second one's a .32, and so on. All right, so assign the subnets to the network shown in the topology. Assign subnet 0 to the LAN connected to gigabit 00 of R1. All right, so they're not saying to configure it. They just want you to label it pretty much. Let's see if I can get that. All right, so this is going to be 192.168. 168.100.0 with a backslash of 27. Make sure you put that, because if you put a backslash 24, it's not gonna work. All right, gigabit 01. All right, so these are all going to go in order. 100. All right, now you have to look up here and say, okay, 32, 27. Now all these should add up to being, if I just add 32 to the 4th octet, they should all be right. 100.64, 27, 192.168.100.32, 6496, backslash 27. All right, I'm going to make this red. All right, assign subnet 4 to the WAN link. All right, that'll be fine. 92.168.100. Is that 128? 27. So you can see right there that's one of the reasons you would use variable length subnet masking, because you're gonna waste a whole lot of IP addresses for that WAN link from router to router. But it really doesn't matter. That's just something to consider. All right, so fill in the addressing table using the following guidelines. Assign the first usable IP address to each subnet to R1 for the 2 LAN links in the WAN link. All right, assign the first usable IP address in each subnet to R2 for the WAN links. Assign the last usable IP address for the WAN link. Assign the second usable IP address in the attached subnets to the switches, and assign the last usable IP address to the PCs in each subnet. All right. And let's see. I need to come here. Actually, what I'll do is maybe do a format painter and like that, and then delete it. All right, so I'm going to pause this while I fill it in, but I'm going to fill in all the IP addresses. Okay, so let's go back up here. So I filled in everything. Notice first usable address for the interfaces for each subnet. All right, same thing over here. And the switches, second usable address. This and this corresponds. This and this corresponds. Looking down here, 97 and 98, and so on. All right, all those should be good. Now skip down here. All right, so assign IP addresses to network devices and verify connectivity. Most of the IP addressing is already configured on the network. Implement the following steps to complete the addressing configuration. EIGRP dynamic routing is already configured between R1 and R2. All right, so configure R1 LAN interfaces. So remember, when it says LAN interfaces, it's talking about the gigabit interfaces, not the serial interface. All right, you can see EIGRP is running because it's doing neighbor stuff. All right. So configure both LAN interfaces for R1. So let's see, interface configure terminal interface gigabit 00 IP address 2.168.100.1 255.255.255.224. Remember, make sure it's .224 is the third octet. Alright, no shut. Alright, notice it gives us a message that says that it's up. And it goes directly over to gigabit 01. IP address. Is it 192.168.100.33? Whoops, 3. And then a subnet of 255.255.255.224. And then a no shut. Alright. Alright, we should be about 46% completed right now, according to my activity window. Alright, so we've done that. Configure the interfaces so that the hosts on the LANs have connectivity to the default gateway. Configure the interfaces. Okay. So I guess that means configure the interfaces so that hosts on the LANs have connectivity to the default gateway. I guess that's turn it on. So we've done the no shutdown. Alright, that one's right, that one's right. Okay, so configure IP addressing on S3. S3 is right here. What's funny, I'm checking the instructor manual and it's wrong. It's funny. It's funny. All right. So if you were typing out, and some people do that, they just type out the answers online, they wouldn't be right. I think that's funny. All right. So where were we? All right. So we want to do configure the switch VLAN 1 interface with addressing. So let's do config T interface VLAN 1. If I could type VLAN 1 IP address. All right. So that was switch 3. So 192.168.24. Whoop. Nope, not 254. 100.66 with a 255.255.255.224. All right. No shut. All right. Let's back up. Exit. Exit. Visit config terminal. Always forget the default gateway. That's it. Alright, there we go. I don't know why it took so long to figure that out. Alright, so our default gateway is from S3 to gigabit 00 is 192.168.100. Make sure I got this right. Gigabit 00 of R2 65 5.255.225.224. Make sure that's right. 65.224. Oh, I don't need the default gateway. Duh. Alright. So that's good. Alright. Configure PC4 with host and default gateway addresses. Alright, PC4 is 2.168.100.126. Subnet mask has to be changed to a 224. Default gateway 192.168.100. And that's going to gigabit 01. Okay, so that's 97. 97. Okay. Alright, so we're good there. Alright, verify connectivity. You can only verify connectivity from R1, S3, and PC4. However, you should be able to ping every IP address listed in the addressing table. Let's go from PC4. I guess I'll try to ping. Let's try to ping gigabit 00 on R1. Gigabit 00 on R1. 192.168.100.1. Alright, so we're good. Alright, that's it. I know there's a lot to that, but yeah, that's pretty much what you have to do. But yeah, sitting down and just learning how to do the subnetting, that takes a little while, but understand that one thing I guess you just had to know, and that they kind of like steered you into borrowing 3 bits. But yeah, I mean, you technically, if you only had 4, say if you had 4 LANs and you only were like, okay, I have 25 hosts, but I only want 4 subnets. You could just borrow 2 bits, right? You could borrow 2 bits, make it a \26, and then you would have 20 or 62 usable host addresses per network. All right. They narrowed it down to use a \27, which gave you 8 possible subnets, but since the requirements were for, let's see, you're given a network address to subnet and provide the IP addresses for the network. Each LAN in the network requires at least 25 addresses for end devices, the switch to the router, right? So if you didn't want to borrow but 2 bits, you could have done it with 2 bits. But anyways, looking down here though, they kind of steered you in. If you borrowed 2 bits, this number would never be a 1 for the borrowed bits. So that's how that ended up. But that's pretty much it. It's all done. So you'll need to submit, and I keep forgetting to say that, but you need to submit the .pka file, copy of your completion rate under check results. Shows, congratulations, whoever you are. There wasn't much configurations on that, and then submit this with these assigned, this filled out, all this filled out, all the answers to all the questions, and that filled out. So there's a whole bunch of stuff in there. All right, but that's it. Thanks for watching. See you later.